Hi there, it's Paul Duvall, co-founder, CTO at Stelligent. At Stelligent, we help our customers embrace DevOps practices such as continuous delivery on the AWS platform. We're a premier partner. We have both the DevOps and financial services competencies, and we've been working with AWS for a decade now. All of our engineers are AWS certified. We work exclusively on AWS. We've worked with customers such as 3M, Verizon, the Washington Post, Citi, several other financial services institutions, to name a few. So I'm going to be taking you through a solution that we've open sourced that allows you to perform continuous delivery with Amazon SageMaker. So I gave this presentation at AWS New York City Summit in July 2018, but since there wasn't a recording of it, I'm going to make one now. So the Amazon SageMaker machine learning service is a full end-to-end platform that really simplifies the process of training and deploying your models at scale. However, there's still some major gaps in enabling data scientists to do research and development without having to go through the heavy lifting of provisioning the infrastructure and developing your own continuous delivery practices to obtain the quick feedback. So in this talk, you're going to learn how to leverage AWS CodePipeline, CodeBuild, S3, along with SageMaker to create a continuous delivery pipeline that allows the data scientists to use a repeatable process for building and training, testing, deploying their models. So the objective really is so that data scientists can spend at least most of their time on tweaking algorithms and experimentation, not in procuring the compute resources, configuring them, waiting days and weeks and months before learning the results of their experimentation. So it's really all about fast feedback and more experiments. So this is a vision that we often share with our customers when we first start working with them. And that is, can any authorized team member have an idea in the morning, have it confidently deployed to production in the afternoon of the same day? And so the answer with pretty much all of our customers always is no, at least for the applications we're working with. But that's the vision that we're seeking. So let's break this down a little bit. So any authorized team members. So this implies a cross-functional team member that's trusted by the team. And then the idea could be a feature, a fix, an experiment, basically any type of change. It could be an application, code change, configuration. It could be infrastructure data. And yes, it could be a change in like a machine learning model. So really anything that makes up the software system. And then it gets confidently deployed. So that implies that it's done in a secure manner. You have reduced risk, that you have a single path to production. You know it's going to go through the same approved process every time on its way to production. And then the afternoon implies that there's a very short cycle time as it goes through that single path to production. So, and since it's in production, we're not talking about a toy or something trivial. We're talking about something that's going to be in the hands of users. So I'm going to cover the basics of machine learning in this presentation, along with how the Amazon SageMaker service helps simplify many of the challenges that data scientists face when building, tuning, training, deploying those models. I'm going to cover some of the basic tenets of continuous delivery and how you can use the continuous delivery service, AWS CodePipeline, to orchestrate and automate end-to-end lifecycle for machine learning. Finally, I'm going to conclude with a couple demos. The first demo I go through is the process of manually using the Amazon SageMaker service to build and tune and train and deploy the models. Then I'm going to show you how you can automate this entire process using AWS CloudFormation along with several other tools. So let's talk about machine learning. So machine learning is a subset of AI in which you can start making inferences without explicitly programming this behavior into code. So instead what you do is you develop or you use algorithms that look for patterns based on usually lots and lots of data. So if you think about it, there are three types of data-driven activities or data-driven development. One is sort of the retrospective data. The other one is the right here, right now kind of data. And then the other is the future, or inferences you can make based on the data that you're scouring. So with a retrospective look on things, you're looking at the past, right? So you're providing analysis and reporting. I would say this is probably the most common look at data. So in AWS, you might be using services such as Redshift or RDS or S3 EMR to analyze it, and then something like QuickSight to view this data. With the right here, right now, what you're doing is more real-time processing and dashboards. So you might be using Kinesis or Lambda, CloudWatch dashboards on AWS in order to analyze and then view the data. And then finally, with machine learning, you start to look at the future. You can make inferences in real time to enable more smart applications. And so you're not really just reacting, you're also inferring. And this is really where Amazon Machine Learning and SageMaker come in. So what does a typical machine learning workflow look like from the perspective of a data scientist? And then also, what are the types of use cases a data scientist is seeking to create these solutions? So common use cases we see include ad targeting, things like credit default prediction, supply chain, demand forecasting, click-through prediction, and there's many others, but those are some of the common use cases. And so often the first step in a machine learning workflow is collecting and preparing the training data that the model is going to use, and this involves getting the data from disparate sources. In some cases, this means converting from a structured or an unstructured to a structured format using ETL services like AWS Glue, or categorizing the data, or making columns or data more consistent, things like that. The second is that the data scientist needs to choose and optimize their machine learning algorithm and their framework. And so they might base it off of a pre-built algorithm such as classification or XGBoost or factorization machines. And then when they choose the framework, there are options such as TensorFlow, MXNet, or CNTK. So, it's not just choosing. You also need to install, configure the drivers for the algorithms, the libraries for the frameworks, and so on. So next, you need to set up and manage your environments for training. In AWS, this means you need to choose an instance type, configure IAM roles and permissions, encryption, network configuration, hyperparameters, and really all sorts of things. And this is much more challenging when you aren't using a cloud provider. The fourth one is then you need to train and tune your model. And this often includes a bunch of trial and error, ensuring that you have the right algorithm, that you've tweaked all the hyperparameters and the data so that you can start to make the right inferences. So next, you need to deploy your model into production. This is where you need to make your model available through an endpoint. So you need to establish your endpoint configuration, your endpoint, you need to ensure it's secure, and so on. And finally, you need to scale and manage your environments. And this is where you need to anticipate and plan for the type of scale your model needs. Here, you're going to be upscaling your compute needs and configuring it to adapt to that scale. So in AWS, you need to configure auto-scaling, you need to configure your environments for A/B testing and all of that. So what's the theme in most of what you see here? So from my perspective, I see a lot of undifferentiated heavy lifting. This is particularly difficult outside of AWS or another cloud provider. But it's also difficult to do this in AWS only using Amazon Machine Learning or only using, say EC2 instances in which you're configuring all this stuff. According to a survey with data scientists, as you might suspect, are happiest building and modeling data, mining that data for patterns and refining their algorithms. And unfortunately, data scientists spend a majority of their time really futzing with this infrastructure. If you look at a lot of these activities, they aren't the types of activities that are around refining and the algorithms and mining the data and things like that. So it's really around infrastructure and configuration, shared servers, laptops, or whatever the other workarounds they might use for training their models. So with Amazon SageMaker, this really simplifies that whole process that I just showed you on the previous slide. So with SageMaker, you get a fully managed platform that enables developers and data scientists to quickly and easily build, train, and deploy machine learning models at any scale. So SageMaker removes all the barriers that typically slow down developers who want to use machine learning. So SageMaker allows you to create a hosted Jupyter Notebook instance at the click of a button, Then it provides you built-in optimized support for the top 15 algorithms, including XGBoost, factorization machines, and image classification. It also supports the top frameworks, including TensorFlow and MXNet. So this means you just choose your algorithm framework, and SageMaker just handles the rest. You don't need to spend time installing and configuring the drivers, the frameworks, and so on. So SageMaker helps with the tuning part using something known as hyperparameter optimization, which is also known as HPO. And so with HPO, it actually uses machine learning to improve the machine learning model. And then you can deploy your models with SageMaker to secure endpoints in one click. It will scale based on its needs, and you can configure it to scale and so forth. So SageMaker handles the hosting, the auto-scaling, deployment of your models. And then all of this can be performed by providing configuration options and then just clicking a button. SageMaker handles all this stuff under the covers. So also SageMaker was built in a modular manner. So you can choose to use SageMaker to only perform one of these actions. So like you can use it to just say deploy your model, or just train your jobs, or train your jobs and deploy your model, and you have your Jupyter notebook somewhere else, for example. So it's up to you to choose how you use SageMaker. So based on what I just went through, it's pretty clear, I think, that SageMaker really simplifies that process for building, training, tuning, deploying models. But what's missing from what I've shown? Well, the first thing is repeatability. So being able to run that same configuration that you may have made to your training jobs, or to the deployment of your model, or to the endpoint. Really being able to reduce the errors by having that repeatability. And you can do that through automation. And so you can ultimately automate the end-to-end process of your models, your endpoints, your training jobs, even your notebook instances. So next one is, how do you integrate the work between what the data scientists are doing in what might be a silo with the rest of the software system? Also, how do you ensure that the work is available to others and not just a single data scientist? Then how do you test your configuration? And then how do you validate your model? And what I've shown so far, what triggers that training job or the deployment of the model to the endpoint in order to make those inferences? The answer is often the data scientist. So they could be sitting on a model for days or weeks without anything triggering an integration other than them, clicking the button. So, and the last part is about security and governance. So this often goes back to that consistency and everything being in version control, and ensuring also there's a process in place that occurs the same way every single time. So let's talk about continuous delivery. So AWS describes continuous delivery as a DevOps software development practice where code changes are automatically built, tested, and prepared for a release to production. It expands on continuous integration by deploying all code changes to a testing environment and or a production environment after that build stage. And so with continuous delivery implemented properly, developers will always have a deployment-ready artifact that has passed through a standardized test process. And Jez Humble, the author of the book on continuous delivery, he describes continuous delivery as making a release as a boring push-button activity that can be performed at any time. So I think that's pretty concise. So what you see in this diagram is that there's a series of stages and really implied actions, a bunch of steps. And then these steps get automated as a part of a fully automated workflow on its way to production. And then here's a bit more of a detailed view on the types of activities that we often get involved in with our customers when we implement continuous delivery, including builds and then many types of static analysis tools and testing types and tools that you're configuring and running, telemetry from dashboards and so on. So AWS describes CodePipeline as a continuous integration and continuous delivery service for fast and reliable application infrastructure updates. CodePipeline builds, tests, and deploys your code every time there's a code change based on the release process models you define. So this enables you to rapidly and reliably deliver features and updates. You could easily build out an end-to-end solution by using pre-built plugins for popular third-party services like GitHub, or integrating your own custom plugins into any stage of the release process. So with AWS CodePipeline, you're only going to pay for what you use. So there's no upfront fees or long-term commitments, just really like most things at AWS. So you can integrate CodePipeline into your existing build, test, and deploy process, as AWS mentions. or you can use an entire suite of AWS developer tools to run your source with AWS Code Commit, or your build with AWS Code Build, and your test with AWS Code Build, or you have lots of different choices when it comes to deployment, AWS Code Deploy and Beanstalk. And in the example I'll show, we use CloudFormation for provisioning the SageMaker models and endpoints and so forth. One of the nice benefits of CodePipeline is it's a fully managed service, meaning you don't need to worry with provisioning, configuring EC2 instances or containers or whatever. So you just model your release orchestration using the CodePipeline console or the SDK or through CloudFormation, which actually I'll show in a bit. So here's a continuous delivery pipeline for machine learning that leverages SageMaker. So the source stage is configured to pull a GitHub repository that contains all the code for the solution, including the machine learning training and the testing, and then the infrastructure code that's provisioned and launches as part of the pipeline. In the build and train stage, we first run CFNAG, which is an open source linting tool for CloudFormation that we developed at Stelligent, and it looks for patterns which may indicate insecure infrastructure. Then we perform model training based on the image classification algorithm. In the example that we're using, but you could use whatever. All you have to do is just make some modifications. And so in this action, we make a call out to the code build service, which then has a script that makes a call to a Python script we wrote that downloads the training validation data in order to actually perform the training. So we configured to run quickly for this demo. So we have it calling a pipeline script that compares one image against another. Now that said, you could potentially use like the output from CloudWatch in order to improve the training performance of the model as well. Where you're using, and really that's the intent of something like this, is that you're using the pipeline in order to not just to build, but train, not just provision and configure, but also train the model itself. So it could be running for hours, depending on what you might be doing. So in the QA stage, we actually launch the endpoint by making a call to a CloudFormation template, which creates a stack that provisions a SageMaker model, the endpoint configuration, and a secure endpoint. And this endpoint is used to make inferences on that model through queries. And then in the production stage, we have an approval process. It's a manual approval process, still part of a fully automated workflow, but someone needs to look at the QA environment and say, yeah, we're good to go. They hit approve. And then it goes and launches the production endpoint and then tests that as well. So let's get into a demo. The first demo I'll be showing is the manual actions that you would perform in creating your notebook instances, creating training jobs, and then also creating your models and endpoints. So I'm going to go through this really fast, but it'll give you a flavor and an idea for what you might do if you need to use the SageMaker console in order to create all these resources. So first thing we're going to do is create the notebook instance. We'll give it a name. We'll give it an instance type. And then we can actually open that. And then we can use a SageMaker example. In this case, we're going to use the image classification algorithm. And so this is it's in the Elastic Container Registry. We're going to create a copy of that. And now we're going to open the Jupyter Notebook. And this is the image classification example. You can see the data preparation, the parameters that you can use and configure, the actual training of the models, how to make inferences, creating the endpoint configuration, testing, and so forth. And then we can shut down that instance when we're done using it. And then you can perform lifecycle configurations against all your notebooks. You can create a training job. We're going to download something from S3 and use that. And this is both the training and the validation data that we're putting in S3 just to make that available, but that would be coming out of a notebook, for example. So here we're creating a training job. We're going to give it an IAM role, and then we're going to choose one of the pre-built algorithms, in this case, image classification. We're going to configure the volume, also the stopping condition, basically 24 hours. Now we're going to choose the instance type we're going to use for training. Then we're going to configure some of the hyperparameters, and this is really tuning our algorithm in the model. Now we're going to choose the content type. We're going to set up the training model, and we're going to point to the location where we've uploaded that. Now we're going to have some validation data. We're going to choose effectively the same options as we did in the training, but it's just a different set of data here for validation. We're done with this. Now we have a training validation models. or training and validation data. We create the training job. And you can see the configuration, the hyperparameters, and so forth. You can also tune, that's the HPO. Now we're going to create the model. It really is just the configuration of the model. We're going to point to the location of that model that was generated from the job. And then we're going to create an endpoint configuration. And then we're going to finally create the endpoint. By creating this endpoint, we can start to make inferences from the data and from the model. Okay, so now we can query the endpoint at any point in time and be able to make inferences based on that data. Okay, so the last demo you're going to see is, now that we've gone through that manual process, you're going to see a fully automated implementation of this solution to enable continuous delivery. And so that means that every time someone has a commit, it's going to go and run through and train your model as a part of the process. But it's also going to run some checks against some of the configuration code. It's going to test endpoints, and anything that you would want to do to verify and validate that your model is operating correctly. You can run queries against the endpoints and so forth. Okay, so we're going to run through this pretty quickly as well, but this is an end-to-end solution showing you how to perform continuous delivery for Amazon SageMaker, but it should give you a gist of all the different components that make up the automation for this solution. So first thing we're doing is looking at the CloudFormation code. This is the code build project. We're running CFN nag as a part of that code build, or that code pipeline action with code build. We have a project for actually performing the model training. You can see it's calling out to a Python script that performs the training job. Then we're going to launch an endpoint and then test that endpoint. So we have a Python script in which we're testing. And then you're looking at the actual pipeline itself. You can see the various stages and actions that are configured in the CloudFormation template. So that creates that visualization that you saw before. So now we're going to launch the CloudFormation stack. We're doing this from the command line, but you could go to the console and run it there as well. And you can see that it's running right now. And then once it's complete, it might take a few minutes to do that, then you can launch the pipeline itself. So now that we have all the resources in place, it'll run through all these steps every single time. And so we're going to make some code changes. And so we're going to that training Python script, and we're going to change the number of epochs, which is really the number of times it's going to be going through the training data. So we change the number of epochs. And then we're going to, you'll see an invocation of the pipelines. So it's going to find the changes from GitHub. It's going to run through CFN nag via code build. It's going to use code build to run that training.py file, which is that program that we just looked at before. That's going to create the training job and download the data and so on. It's going to actually train the model. And then we're going to launch the SageMaker endpoint. We're going to do that through a CloudFormation deploy provider. And you can see that creates the model, creates the endpoint, the endpoint configuration, the endpoint, and then we can query that endpoint. And so in the next action, we actually test the endpoint. So we have a test.py file that verifies the image matches another one. And this is where it's called via code build. And then you can see the test that we're running right here. We're just comparing two different images. And then we have an approval process. So someone needs to actually look at the QA environment and then review it and then approve it. And then it's still part of a fully automated workflow. So every time someone has a change, it's going to go through this process. They approve it, launches the endpoint in production, and then it's going to test the endpoint. So it calls the launching through CloudFormation, and then the test endpoint gets invoked via code build. So that's the end-to-end process of provisioning. So you run a single CloudFormation command. It provisions all your resources. It provisions all the code build projects. IAM, S3, it provisions CodePipeline. It provisions, as CodePipeline gets invoked, it provisions SageMaker resources. You saw the model, the endpoint, configuration, the endpoint, and it's running tests. It's invoking code build in order to create train jobs and run tests, run stack analysis against your CloudFormation templates. And so you can do anything that you would do in a release process, and The key thing here is that it's all running as a part of the machine learning process. Okay, so finally, this is the URL for the open source implementation. So you can go to GitHub under Stelligent's organization. We have a project called SageMaker-Pipeline. If you're watching this really early on, you might not see the blog post, but soon we're going to have a blog post on Stelligent.com's blog. So check that out. We have lots of other blog posts all around DevOps, continuous delivery on AWS. So hope you enjoyed this, and if you have any questions, you can reach out to us on Twitter at Stelligent, or go to our website and you can reach out to us by selecting Contact Us. So thanks a lot for watching.